All right, everyone, welcome back to the land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. This is the second and final installment of this new series, revealing the function of the so-called boat pits located on the eastern side of both the Great Pyramid and Central Pyramids on the Giza Plateau. So buckle your seatbelts and prepare yourselves. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's intro. So without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. Now, to begin, what you are about to see is the culmination of an investigation that began in 2017 during my first trip to Egypt that took its first massive leap forward in 2023 when, in conjunction with my colleagues at the Osireion project, I released the first chemical analysis data revealing the composition of the Giza Plateau iron oxide deposits and the intensity of this on-site examination detailing these features escalated dramatically starting with Sunday Site Visit 2, my second site expedition after moving to Egypt full-time, dedicating my life to revealing the physics and chemistry-based function of the Egyptian pyramids and other ancient structures from around the world. And over the past few years, during various explorations of the Giza Plateau, my work has expanded from concentrating on the interior operation of the pyramids to understanding the function of the entire Giza Plateau structure network. And I have really dialed in on a feature commonly known in the archaeological community as the quote unquote boat pits. And a few weeks ago, my research on this feature hit its climax as I was finally able to get down inside of these components to examine them from a perspective that has never been shown before, as presented in Sunday Site Visit 113. And for those of you that are joining for the first time or missed that video, I'll put in a few short clips now so we can review the details of the configuration before proceeding with explaining exactly how this system operated. Let's go. So this pit is also connected into the channel system. You can see here, there's part of the channel here that runs back into here. It actually starts here and then it branches off into, see, the channel goes here and then it runs further down the plateau here. It branches in this direction here and then comes around into the pit. And this one actually has a really nice termination where you can see this channel here goes directly into the pit. So again, we're going to start on this side and then I'll come back over here. And then I want to hit the, again, boat pits, quote unquote, boat pits in between the satellite pyramids. Then we'll walk over to the central pyramid. All right, so and you can see the vein here. They all start in the core and run in this direction down into the pit. We can see the other side and a little patch right there. This is a patch here, and this is the other side of the vein. I can see there's another piece of it running up here. This is iron oxide here. That goes in this direction. This one goes straight to the next boat pit. So remember, this vein runs from here into that boat pit over there. That's important. These ones, well, this one I might be able to so an important thing to remember if you're jumping into stuff, got to make sure to be able to, just because you can jump in doesn't mean you can jump out. Okay, so let's pick up another one here. Vein into the pit and out on the other side. So there's There's one here, there's one here, and there's one here. So we have 3 veins, these 2, and this one here. And then we have 1, 2, 3 on the other side. Yep, this one right here is patched up with stuff. There's some patches at the top of this here and this one here. Okay, this one also very eroded on this side. Yeah, if the dogs can go in there, why can't I? There's a policeman over there. Again, I don't see, there's nothing down. It's not like there's no signs, and I would go, but well, I guess the worst he could tell me is no. So there's a specific configuration that I'm looking at down in here. So there's a channel that runs down here. And we saw the termination of the channel here. And it opens up here into a rectangular housing down in the bottom of this pit. Okay, so here you can really see there's the other side of the vein that runs here into the pit. This one here. And this other big one, we'll get the other side of this one real quick and see if I have a little better timing on the next one. All right. Yep, so you can see above ground, the vein here runs down into the pit, and then this is the other side here. And this one, follow it straight in this direction, and it goes directly into the next boat pit. Hey, bud. Hey, bud. Well, the worst they can tell me is no. Alright, so you can see the big veins here. Pyramid dog. And this is the housing. Here you can see there's a channel that runs down. Now here we go. East side central pyramid. And according to the archaeology, there's actually 4 pits adjacent to this eastern temple, and they're symmetrical on both sides. We'll have one up here, one on the other side running east to west, and then we have one here and one on the other side running north to south. And I just wanted to come on this side. The one on this end, this is a huge convergence running in through here of iron. And so for this hypothesis that I am contemplating to be true, it has to be consistent across the board with several features. So we're going to look at the extant pits to see if you know, the rationale of my analysis applies to these as well. I kind of already know. I mean, I've only been up here 100 times, so I know that it fits. I just want to make sure. So this is a good deposit in through here. All of this material, all this stuff in here is all iron. And again, these veins start from this direction and then they run out through here. They run through the Eastern Temple. Again, I've extensively documented all of this stuff. So we're just going to pop in here. So we see the exact same configuration on the other side, where you can see that there is an avenue that leads directly. Here's the stone block here. There's an avenue of stones that lead directly into this pit. You can see all this ore material in through. Here's a nice bright red piece. Yeah, and Lex was just pointing out the salt. So it's a very unique form of salt. That's actually a direct piece of evidence that supports my hypothesis for the production of hydrochloric acid in the central pyramid. It's iron chloride. It's not sodium chloride, it's iron chloride. And all of this material, this whole thing is, this whole pit, all in through here, all of this material here. There was a guard over there saying I'm not supposed to go down in there, but I want to show you this vein here. This whole pit is filled with iron oxide. And the reason this kind of dawned on me is because we were walking through here during our expedition to the Osiris shaft, and I saw all of the veins popping out here along the bottom of this formation. And do you have an extra battery?
Yes, I do.
Okay, so if she has an extra battery, I can take a minute to go down in here, because I don't want to just say that these things exist. I know you all saw them last time, but for any new viewers. Okay, so here's that shell. Everybody was dying for me to pop this thing out of here last time. Big fossil. All right, all this is iron in through here. This is all iron deposit. There's a piece of the vein here. There's another big piece right here. Okay. So now I'm gonna, thank you. Let's walk back over here. All right, now the guy's gone. And I want to show you how abundant. This is a big piece of it right here. I'll just show you this. Okay. So this whole piece here is a huge deposit of that metal ore mineral. Hopefully you can see the beautiful color there. And it's on this side. So this part would have connected into this piece here on both sides. Same thing over here. This is another big chunk formation. It would have come out like this. This piece here. Okay. Here's a big, this is probably the one that pops out on the other side that I just showed you, is a piece of this one that connects back into this piece over here. All right, everyone, I hope you're enjoying the video, and please remember to subscribe if you are interested in the function of the Egyptian pyramids and other ancient structures from around the world. And if you want to help support the channel and get access to exclusive research content, check out the members only channel, now up to 25 absolute banger videos. We also have 3 other channels. The new name for my wife Alexa's channel is Archaeoalchemy, a revolutionary new field of ancient site investigation coined by her exclusively. Let's go with Lex and G and the best channel on YouTube, Egyptian Street Cats, for all you cat lovers out there. And if you are interested in joining for the upcoming Land of Chem tour, please send me an email to contact@thelandofchem.com, subject line 2025 Egypt tour, and I will send you the full tour itinerary and pricing details, links to everything in the video description below. Ladies and gentlemen, as always, thank you all so much. Now, back to the video. All right, now, the iron vein network of the Giza Plateau is primarily composed of hematite, chemical composition Fe2O3, a sample of which you can see here on the left, from a geological display case in the Old Cairo Museum. And yes, they have an entire display of the vast array of metal ore minerals and other types of stone that are found in abundance across Egypt, including this iron ore, and a piece on the right from the Giza Plateau, the same iron oxide metal ore mineral. And in episode 131, I began to explain the function of these iron veins, which have also been studied by Dr. Robert Schoch. These are naturally occurring hydrothermal mineral deposits that are teeming with various types of metals, which function in the same manner as occurs during the formation of a Lichtenberg figure, a structure that appears when a dielectric material is subjected to extremely high voltage, causing dielectric breakdown of the material, allowing the current to flow. Dielectric breakdown is a spontaneous transformation from an insulator or dielectric into a conductor, resulting in the creation of these dendritic branch-like patterns. This is exactly what happens to these naturally occurring dielectric iron veins when subjected to the high voltage from lightning. This material, iron oxide, is a dielectric and not a conductor. However, the material spontaneously undergoes dielectric breakdown when subjected to these high voltages, and it allows the current to flow, a process that has also resulted in the vitrification of many of these formations that you've seen me documenting over the past 3 years. Now, samples of this material were collected by my colleagues at the Osireion project back between 2010 and 2015 from various areas across the Giza Plateau, and with my interest and partnership, we finally released them to the public, exclusively here on the Land of Chem, starting in episode 75, focusing at the time primarily on the series of boat pits adjacent to the central pyramid that you can see here. This is an area of particular interest to me that I've been studying since 2017 when I first noticed these iron formations, specifically around pit number 3 here. And I have begun to explore them in depth since moving to Egypt, discovering, documenting, and presenting for the first time ever these massive, spectacular formations that have become so popular here on the channel. Evidence of the ancient hydrothermal forces at work during the formation of the Giza Plateau limestone bedrock millions of years ago. One of the specific reasons that this location was selected for the construction of the Giza Plateau pyramid industrial chemical manufacturing and mining operation, as it had all of the natural resource raw materials that were required to make this system work, including the metal vein wire network and a source of sulfur, specifically hydrogen sulfide. The initial reactant, just like the bedrock methane deposits in Saqqara, upon which the step pyramid was constructed, this source of sulfurous gas is located deep below the surface of the Giza Plateau and was utilized to initiate the chemical manufacturing sequence within the Great Pyramid to produce dilute sulfuric acid, a chemical that is directly connected to the function of the boat pits. A massive discovery regarding these underground geological formations and the presence of hydrogen sulfide, an absolutely massive discovery that was recently revealed in members only episode 20 regarding the function of the Great Pyramid sulfur furnace chamber and the truth of what really lies below the Giza Plateau. Now, in these surface iron ore mineral deposits adjacent to the central pyramid, a vast array of metals have been discovered, including 14 rare earth metals: lanthanum, cerium, praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. But that's not all. We also discovered other metals like tin, 32% in this sample, nickel, 84% in this sample, and lead, 39% here. But also platinum, this sample containing almost 35% platinum, and an interesting combination here, this one with iron, 8%, copper, 9%, praseodymium, 13%, and neodymium, 30%. Here, with trace amounts of thorium at 3%, but also in these iron oxide mineral veins, we discovered highly electrically conductive metals like silver, this one 41%, this one 58%, and this sample a whopping 70% silver. And of course, gold. Here, 8%, this one 33%, and here 37%. And also a sample here with a naturally occurring particle of electrum, both silver and gold. But I'm just warming up. In these iron oxide mineral deposits, we have also discovered evidence of lightning strikes and high voltage electric current distribution through this natural wiring system. Here, adjacent to the so-called trial passages, with this sample, in which a fulgurite was discovered, fossilized lightning that was created as the high voltage electric current fused the silica sand and rock, producing these silica microspheres, direct evidence of high voltage electric current transmission through these iron ore formations that generated these fulgurite silica spheres. And as I mentioned before, iron oxide is not a conductive material. It is a dielectric that will only allow current to flow as a result of dielectric breakdown from extremely high voltage, which is why I describe their function as comparable to that of a Lichtenberg figure, a preferred pathway for the transmission of this high voltage electric current from lightning. And as explained in episode 132, these veins connect all of the structures on the Giza Plateau, leading from the core of the Great and Central Pyramids down into structures like the Osiris shaft, where here, on the second level, I found these huge iron veins in the housings surrounding the containers that distributed the electric current into this subterranean system for the generation of ultrasound and the formation of metal nanoparticles. Check out Members Only Episode 9 and Members Only Episode 13 for the full function of the Osiris shaft. Now, in episode Sunday Site Visit 65, 66, and 67, I began to meticulously map this iron vein system, creating the first diagram that has ever been produced, revealing the circuit network of the Giza Plateau, with all of the pyramids and other ancillary structures connected directly into this massive, high voltage electric current grid network circuit. And if you are new to the channel and this is the first time you're hearing about this, I highly recommend going back and watching the full chemical analysis data and Giza iron vein playlist so you can get caught up. There is a ton of critical research and on-site footage that is evidence for everything that I'm reviewing in this episode. So now I have some new chemical analysis data to discuss that I've been sitting on since 2023, and this is finally the time for it to be revealed, as it is the closest proof that we may ever get to my hypothesis for the products of the Great and Central Pyramids and the function of the boat pits that is about to be explained. So here, adjacent to the Great Pyramid, we have new samples of iron oxide. This one here, relatively pure, with carbon, oxygen, and calcium from the limestone, 61% iron, and less than 2% manganese. This one here, about the same. This one with a small amount of barium. This one, a little bit more interesting, with some aluminum and chromium. And this one here with trace amounts of titanium. All pretty standard. However, there are samples from adjacent to the Great Pyramid that contain sulfur, specifically iron sulphate, which is produced when iron oxide reacts with sulfuric acid. Let me say that again. The sulfur compounds discovered in these samples from adjacent to the Great Pyramid are the result of the reaction between sulfuric acid and iron oxide that create ferrous sulfates. Now, here, adjacent to the Central Pyramid, deep in the bottom of pit number 4, that you can see here, from another sample, another fulgurite genesis silica microsphere was discovered. All right, so now we're in the Eastern Temple. Huge piece of a vein deposit running through this section here. Again, let me not just say that that's what it is here. It went down into this depression. The vein continues here under the floor. And it goes back. You see this black material here is also iron. So the vein continues. It stretches below the entire Eastern Temple. Now, I am going to jump back down in this pit because there's something I want to point out about this vein that I haven't mentioned before that's going to be relevant coming up again soon. So here you can see the same avenue of stones here, these blocks leading directly into this pit. There's actually an injection port hole right here. Again, we've extensively discussed this. I've showed evidence that there's a passageway that leads under here. And I'm going to do this very quickly. Get while the getting's good. Because this is important to point out that I haven't mentioned before. All right, so we've looked at this a ton of times, but something that's very important to point out are concentric circles. There are concentric formations within this iron deposit. And you can see it, patterns kind of running around in a circle. This one here is a very concentric formation, and then there's more concentric formations running through this entire thing. So it's not just an amorphous blob like some of the other deposits. Something very special about that one, and it's a huge deposit. Again, you guys are very familiar with this one already. All this material in through here is all iron. The whole whole pit is filled with iron.
That is so crazy how it's carved out like that.
Yeah.
It's eaten away.
With tons of acidic erosion formations and patterns running through this area. So the veins run down into the pit and continue on the other side. So this is a piece here. See bright red of it there. It leads down into the pit here and continues on the other side. Okay. Oh, this is a really nice piece here. Put it in the sun. All right. And we'll do the same just to be meticulous about today's investigation and make sure we're crossing all the... Okay, so you can see the vein enters on this side into the pit and then continues out in this direction. This area is the largest formation. So this whole thing is all huge deposit, like all of this running through here. This is all iron, huge deposit of iron. You see the vein over there, and then part of the continuation here. Moving down into the southeastern corner of the plateau complex. All right, so one more for today. So again, huge deposit over here connected to an underground tunnel. The opening of the tunnel is right here, now covered up in concrete. Again, I'm not just going to point and say, I'll show you. There's modern concrete here. This is all concrete. There was a gaping hole here, you know, less than 10 years ago when I was here in 2017. That's now covered up with that modern concrete in the center of this huge iron vein deposit. And then we have this. So we have veins running down this way. We have this channel here. I'm walking through the channel. Converges down into the pit. And again, we should see the same thing where the vein running on one side goes into the pit, continues to the other side. Same thing here, down into the pit and off in this direction. And there is tons of acidic erosion. Zayek. Down in through here. Let me if I can get while the getting's good. because I haven't showed this one in a while. Look at all this. And it continues in this direction. The tunnel, I can see this snaking back in this direction. These are all over Giza. We're talking about just subsurface here, you know, less than maybe 5 meters deep. All over the place.
All right, everyone, just a quick announcement. The first book in the Land of Chem series is now back in stock. This gorgeous Egyptian Blue second edition is the exact same text as the first print, but now featuring the new blue color design. Also, a brand new merch shop is up and running, featuring all of your favorite logos, tons of new color options, and my personal favorite, stickers. So whether you are sticking these to the bottom of your skateboard or plastering the walls of your office bathroom stalls, go grab some now and put them everywhere you can find a spot. All available at thelandofchem.com. Thank you all so much for the support. Now, back to the video. The second sample piece of evidence confirming my hypothesis about the high voltage electric current distribution through these components resulting from lightning strikes. We also have some relatively pure samples like this one again. Carbon, oxygen, and calcium from the limestone, almost 65% iron, but also some more interesting ones. This one here with trace amounts of vanadium and again titanium, and this one that we've seen before with about 30% neodymium, also some trace amounts of titanium. But here is where it gets interesting. These samples from the pits near the central pyramid all have chlorine, but you'll notice no sulfur and no sodium. So this chlorine is not from sodium chloride salt, nor are there any sulfur compounds. These samples contain ferric chlorides, which form as a result of the reaction between hydrochloric acid and iron oxide. Has anyone been paying attention? If you have, everything that I have been working towards for the past 5 years should all be coming together. A beautiful symphony of chemistry and physics. Now, with concrete evidence from chemical analysis data, showing iron sulfates from the sulfuric acid product of the Great Pyramid and iron chlorides from the hydrochloric acid product of the Central Pyramid. Let me say that again. The iron sulfates discovered in the samples from near the Great Pyramid are the result of the reaction between the naturally occurring iron oxides and the sulfuric acid product of the Great Pyramid. And these iron chlorides discovered near the Central Pyramid were created by the reaction between the hydrochloric acid product and the iron oxide. So now, ladies and gentlemen, without further ado, what does this have to do with the function of the boat pits, and how did these things operate? Well, let's take a look at the properties of these two products, dilute sulfuric acid and dilute hydrochloric acid. Both are good conductors of electricity. Have you figured it out yet? Let's go to the diagrams that were presented at the end of Sunday's site visit 113. Here, on the eastern side of the Great Pyramid, we have Boat Pit 1, Boat Pit 2, Boat Pit 3, 4, and 5. Now, let's add the iron veins. Done here intentionally in black to indicate the hot wires of this electrical circuit that connect directly into the boat pits and then continue to other structures across the plateau. And these here connecting uninterrupted directly into and below the black basalt paving of the Eastern Temple, another intentional design feature directly related to the Great Pyramid cumulonimbus thunderstorm generator system. You heard that right. Yes, the Great Pyramid itself is a white horse hill. Check out members only episode 19. And so what do you notice here? The boat pits interrupt the iron vein wire circuit. They are breaks in the circuit. And now here they are shown empty. So let's go to the central pyramid and add boat pit 1, boat pit 2, 3, 4, 5, and 6. And again, our hot wire iron veins added in black. With another set here, uninterrupted, going directly into the Eastern Temple, that then continue further down the Giza Plateau toward the Sphinx Enclosure and Valley Temple. So now that we have our integrated circuit network of primary power source, wires, and components, let's open and close the circuit breakers. Did I just blow your mind? Let's go. So here, we have the Great Pyramid being struck by lightning. These stored and concentrated electric fields from which finalize the reaction sequence within the internal reaction chambers, with the remaining voltage distributed out through the core into the iron veins. However, once they hit the breakers, the current won't flow to any other components unless they are closed, i.e., filled with an electrically conductive fluid. Well, it just so happens we have some. So here, we fill the pits with dilute sulfuric acid, a process that creates the sulphate compounds that I just showed evidence for in the sample chemical analysis. Once we close the circuits, the current will flow as desired according to the open and closed position of the boat pit circuit breakers into the various components of the Great Pyramid system and across the Giza Plateau. And don't forget about this pit here, which will send our voltage as needed toward the central pyramid. Now we have the breakers opened here, and the voltage only flows uninterrupted through the Eastern Temple down toward the Sphinx and Valley Temple. This is another intentional engineering design of the Giza Plateau chemical manufacturing and metal ore process industrial electrical circuit. But we can close the circuit breakers with our hydrochloric acid. Again, remember, we have found iron chlorides in these pits that are a direct evidence of this hydrochloric acid circuit breaker closing process. And the current will flow as desired into the Osiris shaft and across the rest of the Giza Plateau. And these boat pit circuit breakers can be opened and closed in whatever sequence was desired for the particular process at that moment, specifically isolating individual structures or areas for a required function, or all closed at once, so the entire plateau system can operate simultaneously. So there you have it, ladies and gentlemen. The boat pits of the Giza Plateau are circuit breakers, intentionally excavated from the bedrock of the Giza Plateau in specific locations to interrupt the iron vein network, allowing voltage allocation control to various components of the Giza Plateau by opening and closing the circuit breakers with dilute solutions of sulfuric and hydrochloric acid. But that's not all, ladies and gentlemen. There's more to the function of the boat pits. So please subscribe and stay tuned. All right, everyone, that is it for today's video. This was episode 169, the function of the boat pits, finally revealed. I really hope you enjoyed today's video, and in the next episode in the series, the function of the bent pyramid, part 3. This is an episode you do not want to miss. So if you haven't already, please subscribe to The Land of Chem here on YouTube. And remember to click that little notification bell so you don't miss out on the new episodes that premiere twice per week. Please like, comment, share, and stay tuned. If you want to help support the channel and get access to exclusive research content, check out the members-only channel and thelandofchem.com. If you want to pick up a copy of the book or grab some merch, links in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our 3 other channels. The new name for my wife Alexa's channel is Alchemy. Check out Let's Go with Lex and G, and the best channel on YouTube, Egyptian Trash Cats. For all you cat lovers out there, ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's episode. So I will see you next time. Yo, are you still watching this? Please subscribe to The Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.